So yeah, let's kick it off for today. Thanks everyone for joining us here in our May meetup, Generative AI on AWS. I'm super excited today. We have two guest speakers that I want to welcome here. We have Sophia Yang from Mistral AI. Sophia, you are the head of developer relations, is that right? At Mistral?
Yes.
Perfect. Thanks so much for joining us today. Sophia will talk here in just a little bit, give us a little bit updates about Mistral AI, new models, about the company, I think, and also we're going to talk about probably the DeepLearning.ai short course that just launched 3 weeks ago with Andrew Ng. And we also have Clay Elmore here with us. Clay from AWS Senior SA. And Clay is going to talk about LLM telemetry with OpenLLMetry and Amazon Bedrock. So super excited for the two talks today. A little bit of housekeeping here. Please ask questions in the chat. And if you don't mind switching the chat here to when you share a question to everyone, so we can see the questions coming in. And then after each session, we'll have some dedicated Q&A time, and we'll go through your questions. Also, the meetup today is being recorded. I put the link in the chat. I'm going to repost that a couple of times today, and you can find our recording on our YouTube channel. And with that, and without further ado, I'm going to stop my share here and hand it over to you, Sophia. Thanks for joining us today.
Awesome. Thank you. Let me share my screen. Hopefully it works. Cool. Do you see my screen?
Yes, we can.
Okay. Slideshow. Cool. Do you still see it?
Yes.
Okay. So the slides full screen. Okay, cool. Thank you, everyone. My name is Sophia Yang. I lead developer relations at Mistral. I'm super excited to be here. Thank you so much for the invite. I'm from Mistral AI, so I want to talk a little bit about our company, overview of our models, our latest model, Mixtral 8x22B, and the underlying architecture MoE, and also show you some demos today. So about us, we are a small company in Paris with over 35 people from Meta, DeepMind, and other cool places. Our founders are from Meta and DeepMind before. And we build the world's best and most efficient models and tools. Our company was launched about a year ago, May 2023. And in September 2023, you may already know that we launched our first model, Mistral 7B. We got a lot of positive feedback thanks to the community. And in December 2023, we released Mixtral 8x7B, also Mistral Medium, and the Plateforme. The Plateforme is our API platform where you can use our API to access all of our models, including open source and commercial models. And in February 2024, we released Mistral Small and Mistral Large, and also Le Chat, which is our conversational chat interface. You can chat with the model through Le Chat without needing to have API keys or anything. It's free to use. And then just last month, we released 8x22B. By the time, it was the best open source model, but the world changes a lot, but it's still one of the best models right now. So here's an overview of all of our models. On the top here, you can see the performance of all the other open source models and commercial models. And as you can see here, our models are quite competitive with all the other models. We have 3 open source models, Mistral 7B, 8x7B, 8x22B. They're truly open source with Apache 2.0 license, which means you can use it for your own use cases, or if you can use it commercially for your commercial use cases. Some of the other open source models are not as open source as our models, so it's truly open source. You can free to use it however you like, which is really nice. We have 2 enterprise grade level models, Mistral Small, which is great for low latency tasks like categorization, writing emails, like simple tasks is great to use Mistral Small. For Mistral Large, it's our flagship model, great for sophisticated use cases, like sophisticated reasoning, RAG, and other use cases. Yeah, our models are multilingual, especially for those European languages. It also performs well in 20 other languages, which is quite nice. We support function calling, JSON mode. You can use us for RAG, and fine-tuning is coming soon. And also we have our embedding model if you want to transform your data to embedded tokens and use tokens for other tasks. It's also very convenient to use our embedding model. Our models are very efficient. For those of you who have experience with Mistral models, you might have known this already. Here is a chart of the performance cost ratio. The x-axis is the number of active parameters in the billions. So Mixtral AX22B actually have 39 billion active parameters. And the y-axis is the performance, MMLU, massive multilingual language understanding. So as you can see here, all of our 3 open source models are highly effective and efficient compared to the other open source models. And in the next section, I want to talk a little bit about the underlying architecture MoE of two of our models, AX7B and AX22B. So the backbone of MoE, the mixture of experts, is the transformer block. Yeah, so transformer is like the essence of all the large language models nowadays. So yeah, everyone's probably already familiar with this. It's composed of 2 layers. We have the feed-forward layer and a multi-head attention layer. And each input actually goes through the same feed-forward neural network. So the feed-forward neural network layers accounts for most of the model's capability. So those weights are super important in defining our model's capability, reasoning, and other capabilities. So now the question is, if we want to add more capability to the model, how can we do that, right? One way is to duplicate our feed-forward networks n times. Because this is so important, we can just do it more and more times, adding more parameters to it. But how do we decide which input tokens goes to which feed-forward network? The solution is to use a router, which maps each embeddings to K feed-forward networks. So you can choose K layers for each input token. So specifically for Mixtral AX22B, each layer we have 8 feed-forward layers, and each token see only 2 experts. We choose the top 2 experts from the feed-forward layer. Yeah, so here's another view. If we have 3 word, the blue cat, just imagine their tokens. When we tokenize the word, it might be like different in different segmentations. But each token will go through many layers of transformer blocks, right? Each layer will have 2 experts each token will see. And for example, the cat will first see experts 3 and 7, and then at a different layer, it will see another 2 different experts. For Mixtral AX22B, we have 56 layers. For Mixtral AX7B, we actually have 32 layers, less parameters. So even though in total, we have 141 billion parameters, because like we have all those experts counting for the number of parameters, because they only see 2 experts, 2 at a time at each layer. So only 39 billion parameters are active. make our model super efficient. So just a brief overview of the performance of Mixtral AX22B. It is optimized for reasoning and knowledge. So as you can see here, the action parameters is super efficient. The numbers are lower than other open source and non-open source models. And it performs really well in reasoning and knowledge benchmarks. It is especially good in those languages: French, German, Spanish, Italian, and English. It is also great in some of the other languages, and we're actively working on other languages as well. And also it's great at coding and math. The performance of coding and math on those benchmarks are also great. So yeah, next up, I want to just briefly show you some demos of how you can use our model through the chat, through the platform, our API endpoint, and also how you can use our model locally. So let me go to the chat first. So the chat is, if you go to chat.mistral.ai, the chat is our chat interface where you can just ask any questions and it will answer your question. You can even edit your question, like, I don't know, write an email to Professor AI, something like that. And then you can interact with our models through the chat. So that's the chat. Right now, we only support 3 models: Mistral Large, Mistral Next, and Mistral Small. Yeah, we haven't talked about Mistral Next. It's our protocol model with extra concision, which means like if you want your model to not be too verbose, you want it to talk less. Some people prefer Mistral Next. So that's something for you to experiment if you want. Yeah, so I have a notebook about how you can use Mistral through our API. So you will need to first go to console.mistral.com to get your API keys. I should have an API key. Okay. Anyways, so you will need to create an API key and get your API key before you can use our API. So just some simple code for you to get started. We first need to pip install our Mistral AI package. And then we can import the Mistral client and also chat messages, which is the format of the message we accept. And you define your client with your API key. To use our embedding model, we define the model as embedding models, and you can give input sentences, you give models, and it can give you responses. If you'd like to know more about different functionalities, we have docs here, and I wrote this embedding guide for you to use, how you can use embeddings for example, paraphrase detection, classification, clustering, and others. Yeah, and most of people use Mistral models for text generation, right? So here you can use the AX22B model, for example, to chat with our model. There are several options, and here are the options of our models. So Mistral Medium is still available, but it will be deprecated pretty soon. So I would recommend you to use the other 5 API endpoints. So yeah, just same thing. You need to define your model. You can define your chat messages. What's the best friend cheese? And the model will give you a response. Yeah, you might want to define your system message in the row or a system message, and then give it a user message. So you can define your chat messages however you like in the list. Yeah, our model also supports JSON mode. So here is a quick example that, for example, have a medical note of a patient, and we want to extract some informations like age, gender, and others, right? We want to return a JSON format with certain JSON schema. Here we define the JSON schema just to make sure the format is consistent. To make sure we enable the JSON format, you can define response format as the JSON object as the type. So this will enforce the model respond with the JSON format. And then you can get a good looking JSON format as your response, and you can use this data later for data processing as easier if it's in JSON. And again, we also have function calling. I'm not going to go details into the function calling. If you check out my course with Andrew Ng on DeepLearning.ai, I spent quite a bit of time on function calling. I encourage you to take a look. Yeah, and I want to leave some time for questions, so I'm going through this quite quickly. Hope it's okay. And finally, I want to talk a little bit about how you can run Mistral models locally. So here's how we do it. First of all, you can download our model through the link from our website. So we have this link on our website you can download. So we download this model, is in a tar, and then we can install Mistral inference. No, this is internal code. That's why I have tokens here. But we're going to release Mistral inference this week, so you can get inference from Mistral super easily. So after we release this week, you will just need to do pip install Mistral inference. It will be a Python package. And then we need to install Mistral common, which deals with all of our tokenizer and other things. So with Mistral inference, we can import the transformer, the generate, and Mistral common. We need to import needed packages like the tokenizer, the format of the messages, and other things. So when you do pip install common, you will get a file called tokenizer.model. You might see different versions, but for our version, we just use tokenizer.model. And we can use Mistral tokenizer to load from this tokenizer file and define the tokenizer. And then for the model, we do transformer from folder because our Mistral models are already downloaded in the folder here. So we can just give it an empty path. It's already the current path. And you can see exactly the details of the model, the Mistral 7B model on your machine. Yeah. And then this is very similar to our API endpoint where you define the messages. Either it's user message, system message, or system message. Give it a chat completion request. And one thing to note that in order for our model to accept what you are passing to, our model only accept numbers, right? That's why we need to tokenize it. We need to tokenize this entire message, not just the user message you see, but also all of this information. It is a user message, right? The role is a user. We need to tokenize this entire chat completion request into tokens. So now we can use our tokenizer to encode the request into tokens. And here's the result of the tokens. It's a list of numbers. And so with the numbers, our model can process. And then finally, we can generate results based on the model, and then based on the given tokens. You might want to define the max number of tokens you want, the temperature you would like to see, and it will output the output tokens and the log probability of each token. And again, the output token is a list of numbers that are corresponding to the tokens in text. And because we defined it 64, this should be a list of 64 numbers. And finally, we need to convert this number back to text. We use tokenizer decode to decode the tokens. And then you can see the result is the text we're interested in. This is the output we can see. Yeah, so this is a very simple repo, a simple way of how you can load our model locally, download our model, and make and do inference on top of it. Yeah, I hope you will find it useful. And finally, I want to just briefly mention again the deep learning AI course that we have. We have introductions on function calling, RAG, and how to make a chatbot with super straightforward code. And yeah. If you want to join our community, please check out our GitHub, our Twitter. We have a Discord, which is super active. We hold monthly office hours there. Sometimes our founders will join the Discord office hour, answer questions. And we have a lot of job openings right now. And so it's a great time to apply for jobs as well. Yeah, thank you so much. Any
All right. Thanks so much,
questions?
Sophia. Yeah, we had a good amount of questions here coming in.
Okay.
First of all, thanks for the talk and the demo here. A lot of questions. Let me just scroll through here and kind of like cluster them a little bit together. I think a lot of folks had questions around the mixture of expert architecture, right?
Okay.
And a little bit confusion. Maybe you can just at a high level give a summary. And I'm just going to point out a couple questions here. Does Mistral models fall under decoder like GPT, only encoder BERT models, or transformer architecture both? And then what are these experts? Is it multi-head attention? And then a deep dive there. Do you have one multi-headed attention block for each of set of the K experts? So maybe at a high level, you can just give a quick overview, I think, to help people understand the architecture a little better.
Yeah, let me share my screen again. Great questions. Share screen. Okay. Yeah, so each transformer block has one multi-head attention block and multiple feed-forward network layers. So even though here I was lazy, I only talked about experts. So the experts we're talking about are actually the FFNs. But each of these blocks, each layers, also include the multi-head attention layer below it. So it's a combination of multi-head attention and the feed-forward layer. So when we talk about experts, it's actually those FFNs.
Okay, and then if you could recap the major difference between the 8x7B and the 8x22B.
Yeah, so it's basically the performance difference. 8 times 22B performs better on all of the tasks, basically, and it has more active parameters. It's just a larger model with more layers, yeah, and different configurations.
Okay, cool. People asked if you could share the notebook, so I guess you can, the Colab notebook that you showed here, so you can put a link in there. I think it's linked from the documentation, right? The Mistral AI docs.
Yeah, so if you go to our docs, each section has a collab that you can open. So I basically combined a few together. I encourage you to go through our docs. Getting started is good one. Also, we have text generation. Okay, this one doesn't have a notebook, but you can see the code, the embedding models, function calling. Yeah, all the notebooks are there. We also have cookbook, Mistral AI cookbook. It has tons of notebooks that you can check out, like quick start. is right here.
Okay, let me just find that link real quick, or if you have it, just post it in the chat here. Box. Yeah, perfect. Thanks so much. As a machine learning engineer expert, how to design build LLMs like Mixtral. So maybe yeah, how could you maybe you could talk a little bit about, what goes into the training. We had a question specifically around the Latin language data set, the size of it, how big it is. I'm not sure if you document that anywhere, but maybe at a high level you can talk folks through that process.
Language.
Yeah.
I'm actually not sure. Yeah. I think we have some data set on that. I'm just not sure the size. But what I can say is our data is high quality. That's why our models are so good. Data is definitely important in the pre-training process.
And maybe another one here, the difference between the open Mistral models and specifically Mistral small medium models.
Yeah.
And also maybe as a follow-up to that, how do people choose like which Mistral model to use, right? If there's any guidance you can give people.
Yeah, that's a great question. We actually have a guide on that. So let me send you the link, picking a model. Yeah, that's the link. So the difference, our open source models are small, efficient, right? 7B is like super small, super efficient. Everyone can use it. You can even use it on your local machine without a GPU. The code I was showing you with 7B on Colab is just running on the Colab regular instance. You can run it as well. So it's super easy to get started, to start iterate. So for our commercial models, especially Mistral Large, is a lot bigger. It has a lot more capabilities. It's more enterprise grade level. So yeah, depending on what you want to use, do you want a small model that you can customize, or do you want a bigger model that's good at everything? So that's the difference. And you can use all of those models through our API. So you can test it out on your different use cases. What we have seen people do is they have a specific use case. They try to see, okay, which model can perform really well. Sometimes they find like Mistral Small perform well enough, like classification tasks, then they just use that. But for use cases, Mistral Small or other models are not doing well, then Mistral Large is probably the way to go because it's just better. Yeah.
Yeah, and I see people ask follow-up questions, how to measure performance, right, of the models. General advice, pick a model that is, supporting the use cases you have, I would say, and then start, with your specific task data set as well. There's obviously, the academic benchmarks that we can use to see how the models generally perform, but then definitely start evaluating after that with your specific data and see how the performance there is. I think that's usually a good advice. And I also want to call out here, we do have Mistral models available on Amazon Bedrock. Super excited. So if you are on AWS, you could also try out, we have Mistral 7B Instruct, the Mixtral 8x7B Instruct, and the Mistral Large model available right now. And we do have model evaluation in Bedrock, so you can also use the tooling available there to start exploring the models if you like.
Right.
People asked, yeah, Sophia, if you could share, you had the last slide there with those, I think the 4 links, if you could just maybe copy paste them in the chat here for people. They were curious to see those links, how to get in touch with you and join the communities. Thanks. And let me repost there.
Oh, sorry. Yeah, I don't know why.
If you switch to everyone.
Yeah.
Yeah, perfect. Perfect. So folks can see it. We had one more question, a little bit more specific. The efficiency point you mentioned in the beginning, someone commented is also important from an electricity consumption viewpoint. And just curious if Mistral has done research looking into the watt-hour and carbon dioxide emissions per million tokens. Not sure if there's any good research around that.
I am not sure. Yeah, sorry, I can't give you a good answer, but I know there are people in my company looking into it. I just don't have the answer right now.
Yeah, no worries. The fine-tuning and RAG kind of explain, and I think you mentioned it, fine-tuning support is coming, right?
Yes.
Yeah.
So for fine-tuning and RAG, check out documentation. So we have good guides on that, and also check out my course with Andrew Ng. Like we have made videos on that as well. Fine-tuning is coming. We're gonna have a fine-tuning API and also show you how to fine-tune our model locally as well. So yeah, you're welcome.
All right. I think in the interest of time, let's wrap the Q&A. I think we got to most of them here. If folks have follow-up questions, they can join the communities, I guess is the best way, right? Probably the Discord and get in touch with the team at Mistral.
Yes. Thank you so much,
Perfect.
everyone.
Thanks so much for joining us, Sophia. It was a pleasure. And yeah, feel free if you need to drop. And with that, we'll hand it over to Clay. Clay, thanks again as well for joining us. And we will switch gears a little bit and talk about telemetry.
Yeah. All right. Thank you very much, Anshi. Appreciate it. So again, feel free to throw questions in the chat. I now have my big monitor up here so I can see what people are saying here, which is awesome. So nice to see everybody on the webinar. My name is Clay Elmore. I'm a specialist solutions architect here at AWS, and I focus on generative AI for our independent software vendors at AWS. So I work with some of the most advanced software companies that we have here at AWS who are using generative AI to perform various business tasks. So what I'm going to talk about today is kind of some observability and monitoring trends that we're seeing here at AWS for our software companies, and how customers of AWS are starting to create these patterns both on Amazon Bedrock and in open source technologies for getting these generative AI workloads into production. So I love answering questions in the chat as they come up, so please feel free to throw them in there, and Anshi will also interrupt me if she thinks that there's one that's really important that I should talk about. So without further ado, let's get started. So I had worked with probably 100 to 150 SaaS companies in the last year and a half who are operating with generative AI. And here's a few motifs that I continuously hear customers' development teams tell me about their generative AI workload. So the first one is, hey, I put this large language model out into some beta environment, and I can't go to production because I don't even know what it's doing in beta. Maybe you know how many tokens it's taking in, maybe you know how much it's costing you, but you might not know the inner workings of, okay, how well is this actually impacting my end customers? Am I certain that I'm going to be getting the correct responses out of this model? And you don't even know that's happening in beta, so how can you move to production? I'm also not sure how to quantify what my model is doing. Things like a Rouge metric for language similarity is not very helpful once you get into these core business processes, which are very nuanced for customers. I'm also spending a lot of manual effort on model evaluation. The amount of AWS customers that I have seen that come in and show us these crazy Excel spreadsheets of manual evaluations for models is not negligible. There's a lot of people doing that at this point. And then I also am using models from different providers. So on Amazon Bedrock, you have access to lots of models, including Mistral that we just talked about earlier today. You might be using the Claude family from Anthropic. And our customers are always trying to switch between these different providers. And that adds another layer of complexity to the 3 bullet points that are above this. So for those of you who have met me before, you would know that I was a machine learning engineer before I moved into this architecture role at AWS. And I built a lot of personalization systems in my past life. And I have an assertion for all of you that is kind of my personal opinion of how I look at observing large language models in production, is that practical large language model observability is very similar to doing observability and monitoring with personalization systems. If you think about the number of levers that you have at your disposal to influence a user experience with a large language model, it is infinite. You can change the prompts, you can change the RAG orchestration, you might have an agent that goes and finds, you can change the different models, you could change, as Sophia was talking about earlier, smaller models versus larger models. It's very similar to a personalization system, which also has these infinite types of levers. And then you're really trying to measure the impact to your end user in a SaaS application. So you're not as concerned with like, do I have the perfect model? You're worried about, did my end user experience get better? And so that's my kind of assertion that I'll bring for the rest of this talk today. I have a framework that I use for application observability in large language models that kind of has 3 phases that I'll re-reference throughout my demo and code snippets today. So the first piece of application observability is pretty standard stuff. So I call this application monitoring. So what is the latency of my large language model? What's my throughput per second? Where are my application bottlenecks? This application monitoring has a little bit of a new Gen AI flavor in the last year. However, it's very similar to application monitoring for traditional machine learning models. So if you were able to stand up an HTTPS endpoint for a PyTorch model, a lot of that application monitoring is going to be very similar for a computer vision hot dog or not hot dog model versus a Mistral large language model. The next piece is much more geared around the user experience to your large language model. So there's typically 2 types of user data that we get from user monitoring, and that's direct feedback and then engagement. So direct feedback would be where you see thumbs up and thumbs down on a chat UI. That's a really good way to monitor your user experience and changes that you're continuously make to production. Engagement is a little bit more nuanced, and engagement has to do with once your users actually interact with the large language model, maybe does it accelerate what you were trying to have them do later? We'll see an example of this in my demo afterward. And then the last one is substantially more complicated for Gen AI. So, and I call this model monitoring. And model is very, very vague in how I'm going to define this. So this might be an agent, it might be a RAG flow, it might be a single large language model, it could be anything like that. There are 2 core types of evaluation that you have to do for these models. The first one is non-ambiguous evaluation. Non-ambiguous evaluation are things that you can quantifiably say are correct or not correct for your large language model flow. So we just got a question in the chat saying, most metrics sound more qualitative than quantitative. No, my personal opinion to all of you is that you have to find ways to quantify the qualitative components that you want in your large language model. So I'm going to show a few examples of that in my demo. So maybe hold up for a second and let me prove some of these things to you as we go on. Non-ambiguous evaluation, though, are things that you can actually check on your large language model. A great example of this is in text-to-SQL use cases. Does the SQL query compile that was generated from the large language model? That is a non-ambiguous evaluation, which you can immediately check for your large language model. And that comes up a lot in our SaaS customers who are generating SQL or generating other pieces of code. The next piece is ambiguous evaluation. And this is where that qualitative aspect comes into play of what is the model saying and does it work well? Those are things that you have to define through your business case. How do you want your model to sound? What types of information need to come out of it? This is where things like hallucination could really come into play. And the last one is API tracing. So with these complicated agent workflows and RAG workflows, how do you actually know what happens when you come into a request to your endpoint? What series of events happen after that? So this is my framework, and we'll see motifs from this going forward. So I'm always interested in open source solutions that are out there. So a few interesting open source platforms that I've seen. pop up for this space and what my customers are using. We're going to see an in-depth demo of OpenLLMetry today. LangFuse is also an interesting open source platform. LangFuse is backed by just a relational database for storing traces, and they also have a open source front end for interacting with LangFuse, so you can literally just clone the repository and do a Docker compose up, which is really cool. And then for those of you who are more familiar with traditional ML systems, MLflow has kind of come into the fold of an open source platform, and LangCheck as well. So that being said, I was interested in these, and so I started diving into what do the patterns look like. So the patterns that these pretty much all follow is that as a SaaS customer, you start with one front-end application, but for every SaaS customer, we all operate with microservices, so that one front-end application is really N front-end applications. You have a bunch of different things that serve some user experience up through N variables. And then we're getting to the point where each one of those front-end applications might have N number of LLM backend orchestration systems that they're talking to, because one front end might not be doing the same thing as the other. You might have a RAG system for your documents, but then you have a chat interface for creating code in another backend orchestration. And so those N number of front-end applications have N number of backend orchestration APIs. Those typically then all get sent to some sort of a telemetry collector. And between the different open source platforms, all these telemetry collectors are different. And so some of them are based on OpenTelemetry protocols. Some of them are simply just relational database schemas, but they all do some sort of like centralized collecting of those traces. And then those telemetry collection, that telemetry collection container will store those in some permanent storage and then surface those in an observability solution. So pretty much all of these that I've looked through go through this orchestration platform, pattern, not platform. So I was interested in what this would look like for an end user experience. So I built one on AWS to see what this would look like. So kind of walking through what I built and what we're going to show in the demo is kind of an end-to-end way of saying, hey, how could I get from this user on the left side of the screen all the way to an application observer? And this application observer might be a data scientist, it might be a full stack engineer, it could be anything that's actually can influence your large language model decision. So inside of our front-end service that I'm just fronting by Streamlit, it could be any front-end that you could use, it could be a React app or anything like that, is going to talk to our generative backend service, which is powered by Amazon Bedrock. That generative backend service is going to have some tooling associated with OpenLLMetry. And that OpenLLMetry tooling will send all of our traces and information that we want to store about our large language models performance to a telemetry collector, which is powered by OpenTelemetry. That OpenTelemetry collector is going to push data into two places. It's going to push it into S3, and it's going to push it also into Amazon CloudWatch for X-Ray. All of those, this way, we now have a comprehensive storage platform that we can store all these traces. Once we're done with storing the data from S3, we're going to do a few things. The first one is this large language model as a judge analysis. So for those of you who have been following this space with large language models, a really popular thing is to start using large language models to evaluate themselves. Now, there are lots of considerations to use against this or to think about when you're doing this. However, I'm very bullish on the idea that large language models are going to be good at evaluating large language models simply because of the scale that you're going to need to operate in production. Having a human evaluate every single output from a large language model is going to become increasingly difficult as we have more of them. So we use Amazon Bedrock, again, to evaluate what our large language model is saying. I'm also going to use an API from AWS CloudFormation to analyze the output from my model. The reason that I'm using AWS CloudFormation is I'm using an application that generates AWS CloudFormation templates. So the Amazon Bedrock language as a model as a judge is evaluating ambiguous components, and the AWS CloudFormation is evaluating non-ambiguous components, and we're going to quantify both of them. After we're done with our trace analysis and Lambda, we'll then push things through a pretty traditional ETL system with Amazon Data Firehose for near real-time data movement, and then being able to query it with Amazon Athena for analytics. So that being said, I'm gonna go ahead and pop into the demo quickly of what this actually looks like in practice. Let's see if I can share this screen again. All right, and so here is the application that I have built on AWS. The use case that I'm going to be going over is what we at AWS call text to DSL. So in text to DSL applications, we're taking some user input and converting it to some domain-specific language, and that domain-specific language could be kind of anything that is codified. So, for example, SQL tends to be kind of a domain-specific language. You could have a proprietary YAML format, a proprietary JSON format, or even a coding language, which you may have created. So I'm going to go ahead, and in this case, I'm creating AWS CloudFormation template. So I'm going to ask my application, make me an S3 bucket. And so once I send this to my application, in the background, my application is then going to give me an AWS CloudFormation template, which actually satisfies this S3 bucket requirement, which is great. On the left side, you can also provide feedback. So I didn't have enough time to put some fancy thumbs up and thumbs down buttons, so you get this response was helpful or not helpful to your application. And so this is generally speaking the use case that we're working with. This is meant to be a very simple application. It's not meant to be crazy. So make sure, like in a lot of your own use cases, you're going to have much more complicated front ends and much more complicated actual applications, but we wanted to focus more on the observability. So once this data is created from our application, it's sent through a series of containers and eventually ends up at this Lambda function, which is our trace analyzer Lambda function. I saw that Anshu just posted the GitHub repo, which houses all the code for this demo. So please take a look at it inside of our AWS samples repo, and I'll post it again at the end of this message, but all of this code is available for you. So this Lambda function is going to actually perform the evaluation of that output that our large language model provides. You can see these come in real time when we start tracing, when we start checking our, oops, here, let's go back to here. Let's monitor this Lambda function. So if we go into monitor and view CloudWatch logs. Sorry, I got a little lost in the console here. These are the console logs for our Lambda trace analyzer. I'm going to ask it to start tailing. So this is going to look at near real-time information that's coming in from our application. So let's go ahead and ask this to modify this. And I want to say, no, I want you to call the bucket play bucket. And hopefully our large language model will be able to alter the CloudFormation template to have the correct bucket name, which is great. So now it's created this. If we pop back over to our tailing logs where we're looking for near real-time events, you'll all notice that in real time, I got these big JSON traces that just popped in. This is the automated data flow, which is happening of, hey, someone is interacting with the large language model. All of that data that's been pushed out to them has been stored and analyzed through this ETL process. If you start breaking down what's in one of these log groups, what's in one of these JSON objects, they get a little unruly, but I will go through a few important things to note. In the middle here, what I'm highlighting is the actual prompt. So this is pretty simple. This is just the text which has been displayed to the user. However, the more important things that you'll now notice is that there's a few pieces of quantifiable information in here. And so in this case, we know that there have been 2 dialogue turns which have happened. So I know I'm on the second piece of dialogue. I have also validated my CloudFormation template with the AWS CloudFormation API. And I know that the large language model has actually produced a valid CloudFormation template, which is codifiable. I then have 2 questions which I have asked the large language model or a different large language model to evaluate the prompt for. I have found no security issues inside of my large language model, which is a little ambiguous. So you might say, hey, make me a VPC which has full internet access and a public IP address. You might need that in some case to happen, but a large language model might say, hey, that's a security risk. That's where these things get ambiguous. And also another ambiguous question is, has my large language model answered my question that was asked? In this case, yes. So I said, hey, make me a bucket, change the name, and my evaluator large language model has said, hey, you have given a helpful response. So that's the near real-time information that's processed through AWS Lambda. If you pop over to CloudWatch traces inside of X-ray traces on the left side, you'll also be able to see the traces which have happened. And so the traces in AWS X-ray are really these things that show you, hey, when an API hit comes in, what happens? So you can see the directed acyclic graph of what is occurring in here. If you click on the bedrock completion and check out the raw data, you'll be able to see all of this JSON information, which is fed in real time. You'll notice that we can see what service we're using, as well as the prompts which are being pushed in to these models. You'll be able to see more specific information, like this large language model request model is Claude Instant. You'll be able to see the max tokens, the request type, as well as the workflow name, which I'll show in the code in a little bit. So if we go back to these traces, something helpful about the trace too is we can see what's taking time inside of our workflow. So we can say, hey, I actually checked my toxicity task. And so I made a post call to the comprehend API. And then after that toxicity check, I came in and actually started my large language model task where I made a GET request to credentials to authenticate my call. And then I made a bedrock completion call after that. And so you can actually start breaking down the time horizon of how long these API calls takes, which becomes really important when you're working with things like agents or RAG orchestrations. All of that kind of culminates into a QuickSight dashboard. And this QuickSight dashboard is supposed to give you a live look into like what's happening in your large language model application. All of these numbers are kind of mocked up. Like, don't put any stock into these and me actually evaluating these models. I was just kind of messing with all of them and showing more of the ETL pipeline. So please don't make any like real decisions about which models perform well and which don't perform well for these cases. But what you'll see is this user helpfulness feedback by model. This is actually this is directly correlated to this button on the left side of the screen. So if you click this button, this response was helpful. You would see in CloudWatch, that's where this data would, or in QuickSight, that's where this data would get updated. The LLM detected security issues and LLM detected an answered question. These are both live evaluations of a large language model as a judge. And you can see that they're split out by Anthropic V2 and Anthropic Claude Instant. So those are the two models that I was testing in my application, as well as the non-ambiguous producing a valid template. So in this case, you can see how many of them produced a valid template in each case. You can also monitor things like latency and user toxicity rate. The point of this end dashboard is in this case, I think I only have a few calls that have come into this. So I think I've only had like 60 or 70 calls that have come into this large language model application. But in production, that could be thousands. Like that could be 7,000 of these per day or something like that. You don't have time to look through all of them. You need an aggregated system to do this. And so what I am encouraging my customers from AWS to do is not to try to boil the ocean with this stuff, but really try to dissect the problem that you're trying to solve into quantifiable metrics, like for example, the one I've shown here. So as I promised, all of the code for this is available on GitHub. I'll make sure that I throw this GitHub piece in the chat. Also, shout out to OpenLLMetry's GitHub page here as well. This is backed by this company called Traceloop. Like, I've really enjoyed working with the open source project. I think it's exceptional. It's based on top of OpenTelemetry so for those of you who have ever done any observability solutions with that, it's a great open source project to get started with. Lastly, I would also like to point out one piece inside of my code. So if you take a look inside of my front-end app, you might ask, how does that data move in between OpenTelemetry and the large language model? And so if you take a look inside of this generate.py function, the Traceloop SDK has these really nice decorators for things like workflows and tasks. And you can just decorate your functions, which are actually doing anything. So in this case, I'm actually checking the toxicity of what these models are providing to me. And so I can do that through the Comprehend API, and I can task this with check toxicity. I also have another task which calls my large language model through Amazon Bedrock. And then I have them all wrapped into a workflow. So this workflow that was defined of generate CloudFormation template is this entire workflow. And then you can see the different tasks like check toxicity and LLM call task all bundled together. So that being said, that's kind of the end of everything that I was going to show today. Key takeaways again is make sure that you're really dissecting your problems into things that you can quantify for these evaluation systems, and then start building your architecture after you understand like what you actually want to quantify in that system. So I'll go ahead and stop my screen share and happy to take any questions now.
Perfect. Thanks so much, Clay. Awesome talk and demo.
Yeah.
We did have a couple of questions here if you want to scroll through too, but I think a couple of folks asked like what aspects, parameters of the model are generally observed.
Okay, yeah, so this is when you say pieces of the model that are observed, I tend to think about, you would most likely dissect that based on the business case that you're trying to solve. So in my case, I was trying to generate CloudFormation templates so for a user. And so you shouldn't think about this as like, hey, what architecture of my large language model do I use to solve that? Like that is not important to your business case. The thing that's important to creating an AWS CloudFormation template is, does the thing compile when you send it to the API? Is the actual template solving the question that the user was asking? So those observed components from an application usability perspective are directly from your business application. Now going on to the technology side, there's a lot of other things that you would observe from like a just core infrastructure perspective. So in terms of application monitoring, you saw that I was observing full turn latency for my models. You saw, and if you dove even further into CloudWatch, you would monitor the amount of tokens per second that you're going to actually throughput through these models, because that tends to be defining of how fast you can get your models out, as well as anything like user engagement that you're observing. I also see a question on how did I define that validate template. The way I defined the validate template is there is an API published by AWS CloudFormation where you can send a YAML file at just like as a string to this API, and it will tell you back like, hey, this thing is valid or this thing is not valid. So it's very fast. It doesn't actually spin up any infrastructure. It's very useful for checking if something is codified correctly.
Right. Someone asked about the observability frameworks for different types of problem. Are there different frameworks for the different types, right? So, for example, answer relevance, context relevance, groundedness for evaluating RAG systems.
I haven't seen a particular like niche of problems that any of these open source components are going after. Like they kind of all go after the agents and RAG workflows immediately. It's just kind of how they go about doing it is different. So I'll compare and contrast OpenLLMetry and LangFuse. OpenLLMetry, which you just saw in my system, is based on the OpenTelemetry protocol. So what that means is that you get these really unruly JSON objects everywhere, which are super helpful because you can shove anything into them at any time. But you then have to deal with the OpenTelemetry protocol. LangFuse is based on just like a simple Postgres schema. And so in that simple Postgres schema, you automatically can query your data once it comes in. It's very, very structured, but it's more difficult to add custom information inside of it. So that's usually for an observability platform, like that's usually the decision point that my customers are going on of like, do I want something that's based on a telemetry system or do I want something that's based on a relational database? Neither are better. They're just different, and choose the one that most suits you at that point.
Right. Okay, question about what if I have non-bedrock models, right? Can I use the frameworks for local models, for example, served via Triton, etc.? Have you come
Yes.
across? Yeah.
Yeah, the answer is yes. So kind of with all these model providers, like you'll get some baked in functionality when you use their own platform. But these open source systems, you can, for example, you can decorate any Python function. So if you can call the thing with Python, you can use OpenLLMetry to trace it, that's part of why I love OpenLLMetry, is that I used OpenLLMetry to trace the user feedback buttons that I had, just because I was like, this is kind of annoying to implement through OpenTelemetry itself. I'm just going to decorate this function and it's good to go.
Nice. And then I think we had a couple of more high-level questions here. Curious about your thoughts, Clay, using Graviton-based chips as an AI compute resource. Have you seen any like performance latency improvements versus x86, or like, so the compute, the networking, which parts play like, you know, a large role in latency improvements there?
Yeah, so this one, full disclosure for whoever asked us, Danny, I don't know a ton about Graviton. Like that's not where I specialize in. So feel free to reach out to an AWS Graviton expert for this. That being said, breaking down stuff in terms of LLM applications, like something that's interesting about them is that like the latency of your application is dominated by the call to the LLM. Like you can think about hosting that front end service on Graviton versus x86. And guess what? Like it's not going to matter to your end user. It might matter to you for some cost performance of your front end service on Graviton or some other ARM chip. But like when you start thinking about the end user latency, it's all dominated by how far that large language model calls us. That being said, like in terms of using ARM chips versus x86 versus GPUs or other accelerated compute for large language models, like there's a lot of traction that's coming into just using local ARM chips, especially through Macs, for running these models locally. So I have a Mac that AWS provides me, and I use what's called OLLAMA to run these models locally. OLLAMA supports not just Llama models, it supports like Mistral models that you saw earlier today. And you can download these models in quantized formats and run them effectively on a MacBook. So I was actually coming back from Hawaii to Seattle the other day, and I was on a plane and I had no Wi-Fi, but I had OLLAMA, and so I could like chat with the Llama 3 just on my plane without any internet connection. So I do think that you're going to see a lot of those ARM chips, specifically Mac for developers, getting used a lot there.
Perfect. All right. We had a couple questions around monitoring for cost as well, right? How can we monitor and control token usage? And also kind of the architecture you showed. What's kind of, how much would this cost a small company, right, to implement? And
Yeah.
I think that, I mean, there's a couple of like different layers to that question, but maybe from a high level perspective, some guidance.
Yeah, so this I'll kind of like take a different angle on this. Like there's lots of stuff out there about how to like design APIs to monitor how many tokens you're putting into it and stuff. Like Amazon CloudWatch, you can set up alarms for the number of tokens, and those are like pretty traditional AWS experiences. Like you push metrics into CloudWatch, you set up alarms to make sure that you don't exceed them, you monitor that cost usage. That's all pretty standard AWS stuff. What I think is really interesting about this question, though, is figuring out how much accuracy you need for cost. That is a hard question to deal with. And so a question that you might have, you might have noticed I was using, this demo was built a few months ago before Claude 3 was out, but I was using Claude Instant and Claude V2. Claude 2 is more expensive, it is more accurate. Claude Instant is less expensive, it is less accurate. How do you make that decision as a developer or as a product manager for a SaaS company? And if the answer you give is like one felt better, like that, you've done a disservice to yourself. Like what you need to do is like sit down and define KPIs, define things that are actually quantifiable, and then make a business decision about like, what is the cost I'm willing to pay for this thing to be better or faster or anything like that. Like those are the types of discussions that I'm starting to get to with customers as we move to this production phase, which are really interesting. And a lot of this is now going to come down to like, how cheap can you make it for how good it is? Like if you start looking at the Anthropic families, like you don't need Opus for everything. Like you might need Haiku for something else simply because it's just cheaper. And you might be willing to sacrifice some of that accuracy in other areas of your system. So you saw Mistral, Sophia's presentation earlier, like the 8x22 billion parameter model is not free compared to the Mistral 7B parameter model. Like how can you get away with using smaller models for cost is really interesting.
Yes. And we had, I think, one last question here. How is the X-ray tracing happening in your solution? Does OpenLLMetry does it under the hood?
So the way that OpenLLMetry, there's two containers that run. Maybe I'll share my screen quickly, give you an idea of what this looks like. Okay, so, and this is all available on GitHub, so check it out. If you take a look at this image right here, oh gosh, that's huge. I had like kind of kerfuffled this, huh? Let's go back. Let's go back to the home page. So inside of this image, this telemetry collector container right here, this telemetry collector is actually two containers. The first container is the front end, or sorry, there's two containers. There's a front end application, which is instrumented with OpenLLMetry, and then there's a telemetry collector. That telemetry collector is the OTel collector container, which is an open source open telemetry collector container. Its entire job is to accept traces from an API producer and then push them to somewhere. I have that collector set up to push to two places. First to Amazon S3, and then secondly to Amazon CloudWatch. The push to Amazon CloudWatch is where the X-ray push happens. So, and that's a native service as long as you have your IAM permission set up correctly in the container. So you can find that in the open source world of how to push those things. And I also, if you give me a second, I could find exactly in this CDK beast where this actually is too.
All right. And while you're getting that, just a quick reminder for everyone. I posted again the links here to the meetup, all other resources. The recording will be shared on our YouTube channel. And also join us next month. Quick plug here. We're going to talk about RLHF, reinforcement learning from human feedback. We're going to talk about another technique called direct preference optimization and how to implement that one on the AWS Trainium instances. All right, and I see you pasted the link here, Clay. Perfect.
Yep.
And with that, thanks so much, everyone, for joining us, for sticking around a little bit longer today. And thanks again to our speakers, Sophia and Clay. Really enjoyed your talks, and enjoy the rest of your Monday. Thanks, everyone.
Have a nice day, everyone. Bye.